Well, it's my great honor and pleasure to introduce the recipient of the Pro Bono Humanum Award, Mary Claire King. This is the second time I've had the honor of presenting an award to Mary Claire. The first time was a year ago when she received the Lasker-Koshland Award for Special Achievement in Medical Science. Mary Claire is truly one of the few people to whom the word transformative really applies. Like most legends, she is a free spirit who for over 4 decades has marched to the beat of her own drummer, animated by the impulse to solve iconic scientific problems, a passion for victims of disease and social injustice, and a warm humility that belies her profound impacts on science, on medicine, and on society. Trained in medicine, Mary Claire began her unconventional trajectory through biological science as a graduate student in statistics in the early 1970s, when she decided to apply statistics to genetics in the lab of Alan Wilson and made the startling discovery that the genes of humans and chimpanzees are more than 99% identical, much closer than previously thought. The ramifications of her findings for how we think about ourselves are profound, and they created a major stir in both the scientific and the lay communities. It's hard to believe that this discovery could be topped, yet that's exactly what she did. Mary Claire accepted a research position to study breast cancer and thus began a 17-year odyssey that led her to discover the first gene defect that predisposes to breast cancer. What was revolutionary about her finding is that breast cancer is a common complex disease, and the prevailing view at the time was that such diseases arise from interactions among multiple genetic and environmental factors that would be extremely difficult to disentangle. But Mary Claire was intrigued by hints that there might be inherited forms of the disease and tested this head-on by studying over 1,500 families in which multiple members were affected by breast cancer. She showed mathematically that clustering of cases could be best explained by the presence of a disease gene in a very small fraction of families, and to test her hypothesis, she set out to determine where the hypothetical gene resides in our DNA, working at the cutting edge to apply tools for gene mapping that were just being developed. She further made the crucial decision to focus on select families in which breast cancer appeared to strike early, a decision in retrospect that was key to her success. And this culminated in 1990 in her demonstration that in those families, inheritance of a small stretch of DNA conferred a 100-fold greater risk of breast cancer, leading her to predict existence of a susceptibility gene in that region, which she called BRCA1 or BRCA1. Her announcement electrified the community at the time, as it has just now, and set off a race to isolate the affected gene. The isolation of BRCA1 and the close relative BRCA2 made it possible to diagnose whether a woman is in an affected family, and an affected family is at high risk of developing breast cancer, and for her to seek prophylactic treatment, as later highlighted by Angelina Jolie. Just as important, I think, in terms of major impact on science, the innovative approach that she took, that is to focus on specific families with striking inheritance patterns of particular forms of a common disease, was a methodological breakthrough that has since provided a roadmap for isolating genetic forms of other common diseases. Mary Claire also had her third big win in that period. She always possessed a strong sense of social justice and had embraced activism, for example, in protesting the war in Vietnam. She had also developed an affinity for Latin America, spending time teaching in Chile after her PhD. There, she witnessed the 1973 coup that overthrew the Allende government and led to incarceration or death of many government supporters, including some of her acquaintances. It's perhaps no coincidence, then, that when approached later by a group known as the Grandmothers of Plaza de Mayo, she was moved to help address the problem of identifying the families of young children in Argentina who had been kidnapped and given to military families during the dictatorship there. In 1984, she reported a first method to help match children with surviving relatives based on a blood test. In so doing, she was a forerunner in the nascent field of molecular forensics. She soon conceived an even more powerful test based on mitochondrial DNA that's been used in matching many more children to relatives and is widely used for identification of human remains, including the previously unknown soldier entombed at Arlington, as well as other soldiers and victims of executions around the world. Mary Claire's relentless probing and her fearlessness when entering new fields help explain both her past successes and her staying power as she continues to make fundamental contributions to both science and society, including on the genetics of deafness and schizophrenia, and in fostering interactions between Israeli and Palestinian scientists. Mary Claire is the first woman to receive the Galien Pro Bono Humanum Award, which makes this presentation even more meaningful. Given the tremendous impact her work has had on women and future generations of women. She's a model for how a brilliant scientist who remains curious, courageous, driven, and compassionate can multiply her impact in a truly magnificent way. Science and society are the great beneficiaries of Mary Claire King's passion, for which we are all most grateful. Thank you, Mary Claire.